So from where we stopped yesterday, we were looking at sector cone transformations. Yes, we're looking at sector cone transformations. Now we have some questions here, about 4 questions. We have 4 questions here. So let's tackle them one after the other. Now for the first question, a cone is made from a sector of radius 14. So let's write down some important facts here. So we have from here, for our question 1, it says a cone is made from a sector of radius. Now listen to the question. Yesterday I gave us some formulas for sector cone problem. That in sector cone problem, the radius of the circle and the radius of the new cone have a relationship given as or given by r is equals to theta r over 360. So where my small r is equals to the radius of the new cone, and big R is radius of, if the question says sector, fine, the same thing, or of the circle. So this is a very important relationship. Okay, so and to the question, a cone is made from a sector of radius 14. Yes, sector of radius. So that should serve as my capital R, sector of radius 14. Let's bring out very vital information here. And what's next? An angle of 90 degrees, that is angle of the sector. Yes, at an angle of 90 degrees, that is the angle of the sector. Theta is equals to 90 degrees. So we are asked to find the curved surface area of this cone. We are asked to find the curved surface area of this cone, and you should know the formula of curved surface area. That curved surface area, as we know, is always equals to pi r l. That is, pi is given to us in the question. We are asked to take pi as 22/7. So we know pi, but we don't know our small r, that is the radius of the new cone. We don't know. And how about our slant height? L here means slant height. So how do we get the slant height? How do we get the slant height? The slant height of this cone. Like I did yesterday, like I told us, the slant height. Whenever you can check the previous video, I wrote that whenever you're given the radius of the sector r, that it's still the same thing as the slant height. So my r is still equals to L. So therefore, my slant height is just same as 14. Yes, my slant height is just the same thing as 14. So whenever you're given the radius of the sector, that serves as your slant height. Always, r is always equals to L. So let's now put it here. To find the curved surface area, CSA is now equals to, my pi is 22/7 times, what is my R? My R, I don't have my R, so times, what is the slant height? The slant height is what here? Wait, we have to find what? Let's check. We have to find what here? Find the, what is the area of the curved surface? Okay, okay, okay. So as you can see now, it's a problem. We are stuck here. We can't proceed to find the curved surface area. You know why? Because we need to get R, small r first. Yes, we need to get small r first. While we know other ones, we know slant height as 14. So we need to get other things first. Of course, we don't know our CSA, that is the curved surface area, and also we don't know our R. So we're having two unknown here. So that is a problem. So how do we get the small r? So at this point, we are quite stuck. So, but there's a way out. At this point, we are quite stuck. To get the curved surface area, we need to know the radius. That is the small r. So, like I have here now, I just told you of something here. Like I have here now, that my small r is always small r. That is radius of the cone, and the sector radius have a very vital relationship. So to get my r is now equal to um theta. What is theta? Theta is 90 degrees. 90 times, what is your capital R? Your sector radius is 14. The radius of the sector or of the cycle is 14 over 360 over 360. So when we punch this on the calculator, let's solve by multiplying numerator and denominator. We would have cancelled by common factors, but let's not get anyone confused. So 90 times 14 is going to give us 1260 all over 360. So 1260 divided by 360 is giving us 3.5. So we have 3.5 centimeters. Yes, that is the radius of the cone. I think this highlight in blue, that is the curved surface area, is now very possible, because therefore I will have that my CSA is now equal to, I have 22 over 7 times, my R was a problem here. That was why we could not proceed. So we've gotten the R now as 3.5. So we have 3.5 times 14. 14. Let's call here over 1. Here over 1. So which is now equals to 22 times 3.5 times 14 is giving us 1078. 1078 all over 7. So which is now equals to 1078 divided by 7 is 154. 154. So our answer becomes 154. And this happens to be an area problem. Curved surface area, we are asked to find it. So it should be in square units. We are using centimeters. So it becomes 154 centimeter square units. And that is the answer for this question. So let's take a look at number 2. A sector of a cycle of radius. So you've heard the word cycle, sector of a cycle. That this sector have or has a radius of 14. So the sector has a radius, so that's my R. Now my R is always the slant height. My R is always my slant height. Yes, R is always equals to slant height. The sector of the radius of the sector is always your slant height of the new cone. That is sector of circle has a radius of 14. So we write 14 is equal to 14 centimeters. So you have to find the radius of the new cone. So this is just a very simple question. So to get the radius of the new cone, there is a relationship that says r is equal to theta r over 360. This is a very important formula. So yes, the small r remains this new cone radius. So that is r equal to theta. Do we have theta here? Let's see whether we have theta here in the question. It's going to complete. Complete. So for number two, I think I had a little adjustment. There was a missing angle, so I checked the question source, and I corrected it. So for question two, a sector of a cycle of radius, a sector of a cycle, that is the radius of the sector, that is your big R, which should become your slant height after the folding in the cone, that this sector is 14 and the angle of the sector is 60 degrees. So let's write it down. We are told that the radius of the sector, that is my big R, that this big R is, of course, your big R is always your equal, it's always equals to L, that is the slant height. So the radius of the sector is still equals to my slant height, and we are told that it is equals to 14 centimeters. 14 centimeters. So we have another fact there that the angle of the sector, that is theta, angle of sector is equals to 60 degrees, and we are asked to take pi as well. Let's see, taking pi as 22 over 7. Pi is equals to 22 over 7. So we are asked to find the radius of the base of the cone, that is to find the small r, to find the radius of the base of the cone. So the formula that best suits this is r equal to theta capital R over 360. Yes, and then you're good to go. So my small r here is now equal to theta is the angle, that is 60 times big R is the radius of the sector, which still means length height of the cone. So this is equals to 14 all over, we have 360. So R is now equal to, so 60 times 14 gives us 840. 840 over 360. So 840 divided by 360 is giving us 2.333 and so on. It's a recurring decimal in centimeters. So let's do some approximation. Let's approximate to the nearest or to one decimal place. So R is now approximately 2.3 centimeters. Or let me see the question if there is a rule for approximation here. Okay, I'm not giving any rule to approximate to, so I can go by choice. So this is now 2.3 centimeters to one decimal place. Yes, so this is your answer. So let's look at question 3. a sector of radius of 7 centimeter and so on. So let's just pick out the vital information here. A sector of a cycle of radius. A sector of a cycle of radius. So this sector has a radius of 7 centimeters. So we can write that my capital R, the radius of the cycle or of the sector is 7 centimeters. So my R is always equals to the slant height, yes, slant height of the cone. So it is 7 centimeters. It is 7 centimeters. Always equates the radius of the sector to the slant height of the cone. That's the rule here. So, and the angle of the sector is 270 degrees. So what else do we have here? Okay, that's all. So that we are told that this sector was used to form a cone. So find the base radius of the cone. So this is just the same thing as, or the same method as example 2. So the formula for finding the base radius of the cone, when we know the radius of the sector, is simply r equal to theta r over 360. So r is now equal to theta is 270 times capital R, that is the sector radius, is 7, then all over 360. So this is now equal to 270 times 7. 270 times 7 is giving us 1890 divided by 360. We are having 5.25. We're having 5.25 centimeters. So this is now approximately, since we are asked to approximate to the nearest centimeters, all our answers. So to the nearest centimeters, which means nearest whole number. This is the whole number here, 5. 5 is the whole number here. So the digit next to 5 is 2. And not up to 5 is 2, so I cannot take 1 from 2 and add to 5, so I'll have to round down. I'll leave it that way. So my answer becomes approximately 5 centimeters to the nearest centimeters. So that is our answer. And now for question part B. B says find the perpendicular height of the cone. Find the perpendicular height of the cone. So yesterday we draw a cone and we saw the different portion of a cone. If I have a cone this way, sorry about this sketch, maybe it might not look nice. So everything here. So this is sorry about this. If I have a cone drawn this way, so and this is the base radius, this is the base my r, which we just found. So we are asked to find this height, this perpendicular height, we have to find it. So that is finding h. Of course, here is your slant height, always your slant height. So how do we find this? This is just basic. We have a right angle triangle formed here, so I can take it out and I will have something like this. So as you can see, this is right angle triangle. Here is my height. My slant height is what? It's 7. We've gotten the slant height as 7. And our radius has been found to be 5.25. Let's use the value that is not approximated. 5.25 centimeters. So this is just basic Pythagoras theorem that we will use here. Since this is a right angle triangle and we know two sides, in a right angle triangle, when you know two sides, use Pythagoras theorem. So what does this theorem state? This theorem states that in a right angle triangle, that the square of the longest side, what is the longest side? Any side facing the angle 90, any side opposite angle 90, any side opposite angle 90 is the longest side. So in a right angle triangle, the square of the longest side, that is 7 square, the longest side, is equals to the sum of the squares of the other sides, that is h squared and 5.25 squared. So we have h squared here. Sorry, we have 7 squared. Or let's get the value of 7 squared. 7 squared is 49 equals to h squared plus 5.25 squared. 5.25 squared is 27.5625. So taking like terms, I will have 49, then plus 27.525 comes to the right, sorry, to the left, and becomes minus 27.5625. I'll be left with h squared on the right. So subtract, do 49 minus 27.5625. 49 minus 27.5625 is giving us 21.4375 equals to h squared. And to get my h, I will take the square root of both sides, which becomes that h is now equal to the square root of 21.4375. So h becomes equals to the square root of 21.4375 is equals to, so taking the square root, we have 4.630 and so on in centimeters. But we are asked to round off to the nearest centimeters. So we have that h is approximately, this is the whole number. The whole number here is 4. We are asked to approximate to the nearest centimeters, meaning the nearest whole number. The whole number here is 4. Next to 4, we have a digit 6. And 6 is up to 5. So I can take 1 from 6 and add to 4, giving us 5 centimeters to the nearest centimeters. To the nearest centimeters. So the perpendicular height of this cone is 5 centimeters when rounded off to the nearest centimeters. Now let's look at the last part, part C. Part C says calculate the area of the base of the cone, and we are asked to take pi as 3.142. Now, this is very much easier. So ask yourself, what is the base of a cone? Now, yesterday we did it. Imagine a cone. A cone, when you look at the base of the cone, the base of a cone is a circle. The base of a cone is a circle. And if we are asked to calculate the base area of a cone, we automatically mean finding the base or the area of a circle. So ask yourself, what is the area of a circle? So the area of circle, as we know, is just equals to pi r square. So the area is equals to, this is the area of the base, since the base is a circle. So my pi, we are asked to take pi as 3.142 times, what is the radius of the cone? What is the radius of the cone? I think we solve for the radius of the cone initially to give us 5.25. Yes, we solve for the radius of the cone to give us 5.25. Always use the value that is not approximated. Yes. So we have the radius to be 5.25. So putting it in our work, so we have 5. Sorry, let me change the color. We have 5.25 now all squared, so a becomes equals to 3.142 times, what is 5.25 squared is 20. So 5.25 squared, I think when you punch we have 27. We have 27.5625. Yes, we have 27.5625. So the area of the base finally becomes, so when you multiply this value by 3.142, you're getting 86.86. Sorry, you get 86.601 and so on. We are using centimeters, so, and this is area, so it should be in square units. Yes, so therefore we are asked to approximate everything to nearest centimeters. So to the nearest cm square of this, a is approximately, the whole number here is 86. That is the whole number here. Next to this whole number, we have a digit 6, and 6 is up to 5 and more. So taking 1 from 6 and adding to the whole number, we have 87. So the value of our area of the base of the cone is approximately 87 centimeters squared to the nearest cm squared. So we have the last question for today. A sector of a circle with radius 21 centimeter has an area of 280 cm square. Okay, this is actually the area of the sector. Come again, a sector of a circle with radius 21 cm. That is sector has an area of 280 cm square. So let's write everything we need for this question. Okay, so um in this case, if you watch the part B is telling saying that we will need to change this sector to a cone. Yes, since this question has to do with, if the question hadn't come with a question B saying that we would change this sector, that is bending it to form a cone, I think I would I would maintain my normal way of solving sector problem. Yes, using that is my small r for the radius of the sector. But in this case here, um, the issue of cone and sector problem has been set. So therefore, be careful with your parameters. In this case, my capital R will be for the radius of the sector, while my small r will be for the radius of the cone. Like I've said, if the question had not talked about cone cone sector problem in part B, I will just use my normal r, my small r, all through. But in this case, don't use small r all through, because small r will now mean for that of a cone, while big R will now serve as the sector radius. So let's continue. Um, a sector of circle with radius 21. So Since this is a cone sector problem, I will have to change variables by using capital R. This R is still equals to the slant height of the cone that will be formed. Like I said, if there was no sector cone problem, no need for this capital R equals to L. I will just use my small r all through. So the radius of the sector is 21 centimeters. Is 21 centimeters. Let me, yes. So, and the area of the sector, area of the sector is 280 centimeters square. So any other information here? 280 cm square. Okay, no. So we are asked to calculate and correct to one decimal place the perimeter of the sector. Okay, so let's recall what is the formula of finding the perimeter of a sector. I think in our previous video we did it there, that to find the perimeter of a sector, P is equals to, I'll have theta over 360 times 2 pi r. Yes, this was the formula we saw exactly. But for this question, let's be careful. This question has to do with sector and cone. So for the sector, I will not use small r again. I'll use big R. This was what I was saying initially in this question 4 problem. So I'm going to use capital R exactly, since the small r will serve for the cone. So let's plug in. Okay, to find perimeter, we need theta, which we don't have in what was enlisted. Our pi is 22 over 7. Our r is 21. So we need theta here to proceed, else we cannot work with this here. So how can I get theta? Because r is known as 21. Let's use a fact from this area, because this value stands for the area of the sector. So I will now write that, let me highlight here. This is what we are asked to find. Okay, so I will now write that, but area of sector is equals to theta over 360 times pi r square. Yes, but since we are dealing with sector and cone, I will not use this small r again to avoid confusion. My sector radius is always big R whenever we are dealing with sector and cone. Now my A here is 280. Put 280 here, equal to my theta we don't know, over 360 times pi. I think we are asked to take pi as 22 over 7. Yes, take pi as 22 over 7 times the radius of this sector is 21. Then we square it over 1 here. So we have 280 equal to, let's multiply 22 by 21 squared. 22 times 21 squared is 9702, and 9702 times theta should give us 9702 theta. So divided by the famous number 360 times 7 is 2520. 2520. So what can we do here? Let's call here over 1, cross and multiply. 9702 theta times 1 is still 9702 theta. 2520 times 280 is 705 600. to get my theta, I'll divide both sides by 9702, dividing both sides by 9702, so that 9702 will cancel out here. I have theta remaining. So 75600 divided by 9702 is giving us 72.72727272 and so on. This 72.7272 and so on. So let's round off to let's round off to 2 decimal places. Yes, this is not the final answer. We are trying to get the perimeter. So I would say that theta is now approximately, let's write here, therefore theta is now approximately 72.72. Okay, or let's do 73 degrees. Okay, or let's just do it to 1 decimal place. 72.7 degrees. Yes. So now we can now proceed to find the perimeter. Finding the perimeter, this blue highlight here was a problem because there was no theta, but we could get theta from an information given to us, that is the area of the sector, which I've gotten to be 72.7. Now let's now proceed. So therefore the perimeter P is now equal to, my theta here is now 72.7 all over 360 times 2 times, we are asked to take pi as 22 over 7, then times the radius of the sector is 21, so all over 1 here. So let's now solve. P is now equal to, multiply the numerator values. So 72.7 times 2 times 22 times 21 should give us 67174.8 all over 360 times 1 times 7 times 1 will give us 2520. And when you divide this value, 2520, we get 26.65666 and so on and so on and so on in centimeters. So but the question says we should approximate to 1 decimal place. Calculate correct to 1 dp the perimeter of the sector. So the perimeter of sector is now approximately, to 1 decimal place means I'll focus on the decimal side only. Focus on the decimal side only. So the first decimal place here is 6 here. That is the first digit after the point. The first is 6. What is next to 6? Here is 5. Yes, it's 5. So I can take 1 from that 5 and add to the 6. It becomes 7. So my answer becomes 26.7 centimeters to 1 decimal place. So that's it. So for part B question, for part B, they said if the sector is bent such that its straight edges coincide to form a cone, calculate to the nearest degree the vertical angle of the cone. So let's locate the vertical angle of a cone. So I have a sketch here for B. Now vertical angle of the cone is this portion here, everything here. Yes, like if I'm to complete this diagram now, let's complete this radius here. Yes, so just everything here, the whole angle here is the vertical angle of the cone, and let's call it alpha. So but for clarity's sake, I had to draw a neater diagram. Yes. So in this case, of course, here is your slant height. This is our slant height. And in a cone, the sides of the cone are equal. Yes, the sides of the cone are always equal. So, and this kind of triangle formed in a cone is known as isosceles triangle. This whole triangle, triangle A, B, C. Yes, everything here is known as isosceles triangle. So, but it is drawn much better here. So we are asked to find this whole part here, find the vertical angle, everything here. So I called it alpha. So this is our slant height, and we have a perpendicular from B that will bisect through this theta, this alpha, sorry, and then to the base of the triangle. And we have our angle 90 here, exactly what it should be here. Okay, so this place is called the radius of the cone, as well as here, since they are equal, the radius of the cone. And let's call here point M. That is the point where they split into equal parts. And this is my A here, and this is my B. So we asked just to find the perpendicular, to find what? Sorry, the vertical angle, exactly. We are asked to find the vertical angle. So, like I said, line AM divides this alpha into equal parts. Yes, it is a bisector. We call it the what? Perpendicular bisector. So it bisects this angle alpha into equal half. Bisect means to divide into equal half. That is, if the whole of alpha, let's say, is 60, this line we divide it into 60 divided by 2, that is 30 and 30. If alpha was let's say 100 divided by 2, that means this part we get 50 and the other part we get 50. So, but we don't know what alpha is. So if alpha, if line AM bisects the angle, we're going to have this portion as alpha over 2. Also, the same thing here, they are equal. I will have alpha over 2. Yes. And so, um, what's next now? To get the vertical angle alpha, I think let's get some information we need for this the question. So from the question, as you can see, we are told that the sector of radius, a sector of a circle with radius 21 cm. So the radius of the sector, that is my capital R, will now become my slant height, as we always do. It becomes our slant height, as we always do. So let's write it here. That for this question here, my R is equals to slant height, which is equals to 21 centimeters. So I know here, what I'm trying to do, I want to use Pythagorean SOHCAHTOA to solve this problem. SOHCAHTOA. Because triangle AMB, right angle triangle AMB, right angle triangle AMB, this B here, this M, and this A. So here becomes alpha over 2. This is my angle 90. So my target is to get this side here, this alpha here. So, but we know the slant height as 21. The slant height here is 21 centimeters. We know it. Um, but we need, let's get the radius. If I know here, it's now easier. If I know this radius, MB, is now easier because I'll apply, this is my angle here. Anyway, the angle is facing down, so down becomes my opposite. and anywhere angle 90 is facing is my hypotenuse. So I can easily use SOHCAHTOA. So let's get the radius of this cone. So as we know from radius of sector and radius of cone relationship, we have that r is equal to theta capital R over 360, which is now equals to, I think we found theta, that is the angle of the sector. I think we found it initially. Yes, we found it. That is 72.7. 72.7. So write it down. 72.7 times the radius of the sector is 21. We've gotten that as well. The radius of the sector is 21. And 21, then let me check. Okay, so then all over 360, so is equals to, multiplied through 72.7 times 21, it's 1526.7 divided by 360. We are getting 4 points. So my r now, the radius of the cone is now 4.24. Let's just stop here. 4.24 in centimeters. Yes, so I can now write here as 4.24 centimeters. I think it's not making sense. So to solve for the angle, the vertical angle, we need theta, we need alpha. Is now, if you watch, like I said, this angle here is facing down. So anywhere the angle is facing is your opposite. Anywhere the angle is facing is your opposite. Anywhere angle 90 is facing is called your hypotenuse, while the other side takes the adjacent. So I have nothing to do with the adjacent. We only need the opposite and the hypotenuse. From SOHCAHTOA, opposite hypotenuse. SOHCAHTOA, opposite hypotenuse. SOHCAHTOA. We need opposite, so I'm going to use sine only. I'm going to use sine. So let's continue. So we are going to use sine, what is the angle there? Sine alpha over 2 is equals to, what is the opposite? 4.24 over, what is the hypotenuse? 21. So if you do 4.24 divided by 21, we get sine alpha over 2. This is a trig function, so let's express the trig value to 4 decimal places as we use in the 4-figure table. 0.2019. Yes. So to get theta over 2, I think we kind of move sine this way. So moving sine this way, but that's not the right thing. We're not moving it in the actual sense. So if sine goes to the other side, we have only alpha over 2 left, equals to, so sine coming here will now become the sine inverse of 0.2019. And when you do that, you get that we'll have that alpha over 2 is now equals to, the sine inverse of 0.2019 is giving us 11.648. Yeah, so to solve for alpha, I think I will call here over 1, cross and then multiply. alpha times 1 is still alpha, equal to 11.648. 11.648 times 2 will give us 23.296. This angle should be in degrees. So, and the question says we should approximate to, let's see, we should round off to the nearest degree. So, to the nearest degree means nearest whole number, and the whole number here is 23. What is next to this person is 2. That is the next digit there, and it is now up to 5. I can't take 1 from there, so my answer becomes that alpha is approximately 23 degrees to the nearest degree. Thank you.